Welcome to CSEGURU. In this session, we will discuss the topic C program to implement circular queue operations. Already we have discussed what do you mean by circular queue and what are the operations we can able to perform with circular queue. Now, in this session, we will discuss a C program to implement the circular queue operations. So here, initially, you have to declare front equal to -1 and rear is -1 because this is the condition for empty queue. Then the operations are insert, delete and peak operation, and also the elements if you want to display in this is you have to use display operation. Okay, so these four operations we will implement with C code. So here this is the menu: insert, delete, peak and display, and final exit operation. Then you need to enter the option. If option is 1 in the sense, it will enter into case 1, it will implement insert operation and then break. If option is 2 in the sense, it will implement delete operation. And here, if value is not equal to -1, meaning is queue is not empty. If queue is empty in the sense, value it will return as -1. Okay. So if value not equal to -1 in the sense, it will display what is the element it has deleted. Okay. And then it will break. If case is 3 in the sense, that is option is 3 in the sense, it will implement the peak operation. And here also, if value not equal to -1, that is circular queue is not empty in the sense, it will display the front element. And case 4 in the sense, it will implement the display operation. If case 5 in the sense, it will break from the switch statement. So here, this is the insert function. And here, first step is you need to enter the number to be inserted into the circular queue. So what is the number you want to insert? That you have to enter here. For example, I want to insert 50. Okay. And here, if front is equal to 0 and rear is equal to max -1 in the sense, what is the meaning? Circular queue is full. Okay. So here, whatever the memory you have allocated for all the memory locations, elements are placed. That is the meaning. So here, front will point the first position and rear will point to max -1 position. Okay. So here, this is 0th location, 1, 2, 3, 4, 5, 6 and 7. Okay. So now front is pointing to 0th memory location and rear is pointing to max -1. That is 7th memory location in the sense here it will display overflow condition. Okay. So this is one case. And next is if front is equal to -1 and rear equal to -1. So here front and rear both is pointing to -1 memory location in the sense, what is the meaning? Circular queue is empty. So in that case, what we have to do? We have to set front and rear to 0th memory location. I want to insert element 50. Okay. So here in this case, overflow condition, you cannot able to perform insert operation. Okay. If front is 0, rear is max -1 and it has to display overflow condition and you cannot able to perform insert operation. So here in this case, if front is -1, rear is -1 in the sense, it will represent the empty circular queue. Okay. So here if you want to insert an element, you have to reset front and rear pointer to 0th memory location. You have to set. So front pointer to 0th memory location as well as rear pointer to 0th memory location and place this element 50. That's it. If front and rear is -1, this is another case. Suppose if rear is equal to max -1 and front is not equal to 0. Okay. So here rear is equal to max -1. Max -1 position in the sense, this position rear is pointing. And the front is not equal to 0. Here front is pointing in the sense. So what is the meaning here? 30, some 70, some elements are there. Okay. So in this case, how we will implement insert operation in the sense, normally we will increment the rear pointer position by 1 and then place the element. But here the rear pointer has reached the maximum position. Okay. Further, we cannot able to increment the rear position from here. Okay. That is not possible. So what you have to do? Here in the front pointer position, already we have inserted 3 elements and we have deleted also. That's why front is pointing here. These 3 memory locations, previously elements was there. Now we have deleted. Now these memory locations are free. So how we will perform insertion in this case in the sense, if rear is max -1 and front is not equal to 0 in the sense, set rear is equal to 0. Now the rear position you cancel this one and reset the rear position to 0th position. And then place the element. What is the number? 50. So place the element 50. If rear is equal to max minus 1 and front is not equal to 0. Last case is increment rear position and place the element. So this is the normal case if the previous conditions is not at all satisfied, in the sense all these cases is failed, in the sense just to increment the rear position by 1 and place the element. So for example, consider this circular queue and rear is pointing to 4th memory location, front is pointing to 0th memory location. Here front is equal to 0 but rear is not equal to max minus 1. So this condition fails. And front and rear not equal to minus 1. This condition also fails. And here rear is not equal to max minus 1 and front is equal to 0. This condition also fails. So in this case, what we will do it in the sense, just to increment the rear position by 1. Now rear is pointing to 4th memory location. Just to increment the rear position by 1. Now this will be cancelled. Now rear is pointing to 5th memory location and the element 50, place it in queue of rear. 50, element 50, you place it here. Now rear is pointing to 5th memory location. Okay. Can you able to understand all these cases? So here front is 0, rear is equal to max minus 1, in the sense all the memory locations whatever we have allocated, all the memory locations elements are placed. In this case only circular queue is full. Okay. So in this case you have to display overflow message and further you cannot able to perform insert operation. And front and rear is pointing to minus 1 memory location, in the sense circular queue is empty. Reset front and rear pointer to 0th memory location and then place the element 50 in queue of rear. Then third case is if rear is max minus 1 and front is not equal to 0, in the sense meaning here is previously in the front pointer location elements were placed and we have deleted that memory location. Currently it is free. So after rear has reached the maximum position, reset the rear pointer to 0th memory location and then place the element. Suppose if all these case fails, in the sense just to increment the rear pointer by 1, meaning is rear has not reached the maximum position. Still the memory locations are free. So directly you can increment the rear position by 1 and place the element. Okay, so this is the cases for insert operation in circular queue. Next, delete operation in circular queue. So here if front is equal to minus 1 and rear is equal to minus 1, in the sense circular queue is empty. That is the meaning. So in empty circular queue, you cannot able to perform delete operation. There is no element in the circular queue. Then you cannot able to perform delete operation. So it will return underflow message and it will return the value minus 1. Okay. Suppose if this condition is false, in the sense that is rear and front both is not equal to minus 1, in the sense meaning is in the circular queue value is there. Okay. And what is the circular queue front pointer value? That you have to place it in variable val, and then if front is equal to rear, front and rear both is pointing to same memory location. For example, here if front is equal to rear, what is the meaning, in the sense here elements are there already. Okay, but what happened? Initially front is pointing to 0th memory location and rear is pointing to 3rd memory location. Okay. So in which case front will be pointing to, front and rear will point to same memory location. Here the front pointer is deleted, here it is deleted, here also it is deleted. After that, now front will point here. Already have inserted the elements, but I have deleted in this memory locations. Okay, now front is pointing here and rear is also pointing here. In this case, what we have to do? Set front and rear to minus 1. After deleting here, set front and rear to minus 1 memory location. Meaning is circular queue is empty. That is the meaning. You can restart from the first memory location itself. Okay. That is the meaning. That's why we are resetting front and rear pointer to minus 1. Okay. Once you have deleted the last element in the circular queue. So this is one case. Else, if front is equal to max minus 1. Suppose front is equal to max minus 1 position, in the sense. What is the meaning now? The maximum position it has reached. And rear here it is pointing to 3rd memory location. How this case will happen? Here in all the memory locations from 0 to 7th memory location we have placed the element. And from 0 to 6th memory location, whatever the elements is there, already we have deleted. So now front is pointing to 7th memory location. And this free memory locations, further insertion, we have incremented, we have reset the rear position to 0 and we have placed the elements. Now rear is pointing to 3rd memory location. So in this case, what we have to do it in the sense, set front to 0th position. So from maximum position, you are resetting front pointer to 0th position. That is the meaning. Okay, now this element will be deleted. After deleting this element, reset the front pointer to 0th position. Else, just to increment the front pointer. If this case also fails in the sense, just to increment the front pointer by 1. So how we will increment the front pointer in the sense, this is the normal case. Suppose if this is the circular queue in the sense, now front is pointing to 0th memory location in the sense, here the first condition, front and rear is not equal to -1, this condition fails, and front is also not equal to rear, this condition also fails, and front is not equal to max -1, this condition also fails in the sense, just to increment the front pointer by 1, automatically element will be deleted. Just to increment the front pointer to first memory location, this 0th memory location element will be deleted. Okay, that's it. So these are all the cases for delete operation. Here this is the empty circular queue condition. Okay, and here front equal to rear in the sense, what is the meaning? Elements we have inserted and we have deleted few elements. Now rear and front is pointing to same memory location. So after deleting this element, just to reset front and rear pointer to -1, else this condition if you are considering in the sense, the front is equal to max -1. That is, in the circular queue, all the positions we have placed the element and up to the 6th memory location, we have deleted the element also. Okay, in this case, what we have to do? The front pointer, after deleting this memory location, just to reset front pointer to 0th memory location. If both this condition fails in the sense, meaning is, this is the normal case, we have inserted some elements in the circular queue and front pointer, it is pointing to some memory location. If you want to delete that element, just to increment the front pointer by 1 memory location, then automatically previous memory location element will be deleted. Okay, so this is circular queue deletion. Next is circular queue peak operation. So here also, before implementing the circular queue peak operation, we have to check whether the circular queue is empty. So if front and rear is pointing to -1 memory location in the sense, circular queue is empty, it will return -1 as the result. Else, just it will return queue of front. For example, if this is the circular queue in the sense, here elements are placed in the sense, what is the front pointer memory location? Just it will return the element of front pointer. Front is pointing to 0th memory location and here value is 10, it will return 10 as the result. That's it. Suppose if this is deleted and front is pointing here, the first memory location in the sense, in this case, it will return 20 as the result. Just it will return the value placed in the front pointer position. That is nothing but the peak operation or otherwise called front operation. Next is display operation. If front is equal to -1, rear is equal to -1, this is the condition for circular queue is empty. Else, it has to check if front is less than rear. Front is 0th memory location, rear is 3rd memory location. Yes, this condition is true in the sense, using the for loop with the rear condition up to this rear position 3, from 0th memory location, it will display the elements one by one. So first iteration, it will display 50, second iteration, it will display 100, third iteration, it will display 70, and then it will display 90. Then this condition, for loop condition will fail, it will exit. This is one case. Else part, how we will check it in the sense, suppose if this is the circular queue condition, that is, already we have inserted the elements and rear has reached the maximum position. After that, we have reset rear to 0th memory location. And from 0th memory location, we have placed the element. So in this case, how we will display the elements in the sense, here two for loop conditions we will use. One for loop condition to display the element from front to maximum position. This is the maximum position. So here I is equal to front. Front is 6th memory location, 6 less than 7. And it will display the element in 6th memory location, 80 it will display. Okay. Then I will get incremented to 7. Sorry, here maximum position is 8. Okay, not 7. Then it will check the condition 7 less than 8, condition is true, and then it will display the element 90. Okay, up to this maximum max minus 1 position, it has displayed the element. So this is the queue it will display. Then using another for loop, what we have to do, I is equal to zeros from 0th memory location up to this rear memory location. I less than or equal to rear position, that is 0 less than or equal to 2. Up to these positions, it will display circular queue like this. So here it will display 20, 60 and 50. Then this for loop condition fails and it will exit. Okay, can you able to understand the difference? This for loop is from front position to max minus 1 position. It will display the element. Wherever the front it may be, up to this max minus 1 position, it will display the element. And this for loop condition is from 0th memory location to the rear point location, it will display the element. So this for loop is normally it will display the circular queue. Okay, from front position to rear position. Suppose here in circular queue, if rear has reached the maximum position in the sense, afterwards we will reset rear to 0th memory location, right? So if 0th memory location is free in the sense, you can able to place the element from here. That is possible. So to display the element from front pointer position to max position, you are using one for loop. And from 0th position up to this rear location, to display the elements, you are using another for loop. This is the difference. Okay. So this is the C code to display the elements in circular queue. So these are all the basic operations we can able to perform in circular queue. enqueue, dequeue, peek and display operation. Thank you for watching this video.